This is section 2.4, rates of change and tangent lines. First thing we need to talk about is some definitions. An average rate of change is known as this secant line. It is a line through 2 points. Secant. Uh, Average rate of change.
Good morning.
Morning. Its formula looks like this. F of B minus F of A over B minus A. Should have seen that at some point in pre-calc, and hopefully you know by this point it is the glorified slope formula. I don't know why I made an equal sign there. There we go. The instantaneous rate of change.
So inspire. Okay. Does anybody not have inspire that needs the slope or needs the tripod? Okay, okay. I got the application if anybody needs it.
Okay.
That you could, it installs on the 84. It's really easy to. But
they all have inspires because I
Yeah.
make them have inspires for this class because it does several things
Okay.
that it doesn't. The instantaneous rate of change is called the slope of the tangent line. And the formula for that will be the derivative. Okay. Those are
After that, the base sequences and series of seven.
terminologies that you're going to need to know. Okay. Tangent is essentially the slope of the curve at a single point. The tangent line can be found from this little formula that we used in pre-calc. Do it another color. Called the difference quotient. And what's going to happen is you're going to be applying the limit as not x, h approaches 0. So you're moving towards a point where you're dividing by 0, which is a problem. So this piece right here, known as the difference quotient. Okay. And one way of looking at it, there's another way where you can look at it with these points A and B approach this point here. You'd actually probably put A here and say B is approaching it. There's a couple ways to look at this. So now we're going to do x squared at the value x equals 2. So we're looking at this particular function. So limit as h approaches 0 of, can you guys keep it down a little bit? I'm actually recording this for Holman. So this is a little nice because I know the x value, I can plug in 2. And now I just have to simplify this limit. 4 plus 4h plus h squared. So I squared the binomial, not squaring the two parts. Minus 4 over h. Fours cancel, leaving me with 4h plus h squared over h. I again can now I can cancel an h from each of these. And now it's time to write the fact. I haven't been writing the fact that this is a limit all along, but it still is. 4 plus h. Well, now as h goes to 0, 4. That makes sense?
Yeah.
Not super bad. We're going to do a harder one now. Actually, I'm going to erase, so I want to leave the difference quotient there. So it's visible. Okay. This time f of x equals 1 over x. And it says x equals a this time. It's going to have me do negative 1/4 in a second. So limit as h approaches 0 of 1 over a plus h minus 1 over a all over h. To do this, I need a common denominator. To get the common denominator, I multiply each one by the other's denominator. That makes sense?
Yeah.
So I've got a. Let's go back to black. We've got a over a times a plus h. I'm not going to bother distributing. Minus a plus h over a times a plus h.
Hi,
Right.
could you tell me which classes are your dual credit? I mean,
No,
some of them are very obvious, but
no, no. Yes, 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 yes. No, 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 no. So all of them that are dual credit have a DC here.
DC, oh, perfect. Okay, thank you. That is helpful.
That's still a credit. This is not.
Okay,
So.
thank you.
Mhm. So now a little trick. Oh, it's still over H. I shouldn't forget that. I do this. plus negative. These are a common denominator, so I can just go ahead and add them together. And those will cancel out, leaving me with this negative h over a plus h. This divided by h piece is the same as multiplying by 1 over h, which then allows my h's to cancel. And I get limit as h approaches 0 of negative 1 over a times a plus h, which is negative 1 over a squared. The beautiful thing, they say now it says, where does the slope equal negative 1/4? So that gave me this is kind of a general formula. A can be whatever I want.
Right.
Now I can just set this negative 1/4 equals negative 1 over a squared. A is 2. If you want, you could cross multiply and solve, but hopefully you can recognize that, oh, this a squared is equal 4, 2 squared. I suppose a is actually plus or minus 2. Because negative 2 would work as well. That is a little advantage to solving. So the last question here asks me, what happens to the tangent to the curve at the point a, 1 over a, for different values of a? So the tangent, when a gets very small, 1 over a gets very large, correct? So this is a graph, and I can think about it in terms of the graph. So the graph in another color. Look at the graph up here. It looks like this. The tangent gets very close to 0 on these outer parts out here. It gets very close to infinity as we get close to 0 on these parts. Tangent line very steep. That makes sense?
Yeah.
And those are the descriptions. Okay, that's tangent line. A normal line. I'm just gonna scroll down. A normal line is perpendicular to a tangent line. So in order to find the slope of the normal line, we find the slope of the tangent line, and then we do opposite reciprocal. And again, here's my formula for finding the slope of the tangent line. So the question is, write the equation for the normal line of f of x equals 4. Oops, that's kind of sloppy. 4 minus x squared at x equals 1. So, I forgot my 0 on my formula. Four minus, the little trick here is I have to plug in 1 minus h for the x. And I must also use parentheses around the f of x. This gives me 4 minus 1 minus 2h plus h squared minus 3. Now I'll distribute my minus 4 minus 1 plus 2h minus h squared minus 3. 4 minus 1 minus 3 is 0. And again, something like that should always cancel out, or you did something wrong. Over h, leaving me with limit as h approaches 0 of 2h minus h squared over h. I can cancel, now I have an h in every term, so I can cancel my h's. Must wait until I have an h in every term. Equals limit as h approaches 0 of 2 minus h. H goes to 0, so that is 2. The slope of my tangent line is 2. The slope of my normal line is -1/2. Now, I know x equals 1, but I don't know the y-coordinate. So I need f of 1 equals, I plug it into the original equation, 4 minus 1 squared equals 3. Now, I'm going to write the equation for the normal line. Pretty much I always use point slope for this, giving me final answer y minus my y-coordinate is 3, -1/2, x minus my x-coordinate was 1. That's the equation for the normal line. Okay. Last thing we're going to do is talk about a free fall problem. Similar idea. Calculus application of a physics problem. So, find the speed of a falling rock from section 1 at t equals 1. We have the speed of a falling rock in feet per second follows basically the formulas we use in physics, 1/2 acceleration due to gravity times time squared. We're saying downward is positive, makes it simple. Acceleration due to gravity in feet per second is 32. So you see y equals 16t squared here. It says find its speed at 1 second. So that's its instantaneous speed. Limit as h approaches 0. F of x plus h. 16 1 plus h. So again, I could use t plus h, but I could just use 1 because I know my value of t is 1. Minus 16 times 1 squared is 16. It's a nice easy one. So now I square my binomial. 1 plus 2h plus h squared. I distribute my 16. My 16s ever so nicely cancel out. Giving me 32h minus 16. I don't know why I have a t squared. That should be an h squared. That was supposed to be an h. Over h. I can cancel one of my h's from each of these. not the whole h, but just 1 from the h squared, giving me limit as h approaches 0. Did I do that? Of 32 minus 16h. Now I can plug in 0 for h, and I get 32. Instantaneous rate of change is feet per second. And that's section 2.4.